So today, we're going to talk about something that works almost completely behind the scenes, but is, well, more critical than ever. We're talking about the invisible shield that protects soldiers, cities, and entire nations from attack. We're going to dive into how modern air defense has been forced to evolve at a crazy fast pace. Okay, let's get into it.
And really, it all boils down to one fundamental question that military planners everywhere are grappling with. How in the world do you stop a threat that's faster, smaller, and smarter than anything you've ever faced before? A threat that might be flying so low or so fast that your old systems can't even pick it up.
Because here's the thing. The sky today isn't empty. It's a crowded, complex digital battleground. This image here really gives you a feel for it. It's not just about one plane versus another plane anymore. It's a whole web of sensors, interceptors, and threats, all talking to each other, all happening at once.
So, first, let's get a handle on what's making the skies so dangerous in the first place, because the game is completely changed.
The threats we're dealing with now are just a totally different animal. We're talking about swarms of cheap but really effective drones, UAVs. You've got cruise missiles that literally hug the terrain, flying at super low altitudes, sometimes just 20 meters off the ground, just to hide from radar. And then you have these high-velocity, super maneuverable assets with tiny radar signatures that are just incredibly hard to track. The main point is, these are not your grandfather's bomber formations.
And look, this isn't just theory on a whiteboard. The world got a very real, very public demonstration of this new reality just a couple of years ago, in a conflict that pretty much changed everything.
The 2020 war in Nagorno-Karabakh was a massive wake-up call for military strategists around the globe. It was just a clear, brutal lesson in how these new technologies, especially drones and advanced missiles, could completely overwhelm older traditional air defense systems.
But, and this is the important part, it also showed us the solution. In one incredible moment during that conflict, the Azerbaijani army used its Israeli-made Barak 8 air defense system to do something amazing. They shot down a Russian-made Iskander ballistic missile while it was in flight. Now, this wasn't some lucky shot. This was proof that a whole new way of thinking about air defense actually worked.
So what is this new philosophy? Well, it's all about the network. The power isn't in one giant missile anymore, it's in the intelligent system that controls all the moving pieces.
You know, what's really fascinating here is the contrast. On the one hand, you have legacy systems like the old S-75s. They were built with specialized standalone parts. You had one radar for tracking, one launcher for firing, basically one system for one job. The problem? You could overwhelm them, just throw too much at them at once. But modern systems like the Barak 8 are designed from the ground up as an integrated network. All the modules, the radars, the launchers, the command centers, they all work together, which makes them way more flexible and way harder to beat. And this right here perfectly illustrates that idea. On the left, you can see the concept of the Barak MX network. It's like a digital umbrella that connects all the different pieces. And on the right, you see the actual tools it uses, a whole family of different interceptor missiles, each one designed for a specific job, a specific range, and a specific kind of threat. And the system is really smart about which tool it uses. This is what creates a layered defense. So for a threat that's pretty close, it might use the Barak MRAD, which has a 35-kilometer range. For something a bit further out, it can launch the LRAD, which can reach out to 70 kilometers. And for a really high-priority long-range target, like that ballistic missile, it brings out the big gun, the Barak ER, which has an extra booster that pushes its range all the way out to 150 kilometers. It's all about having exactly the right tool for any job that comes up.
Now, the secret sauce that makes all of this work is the software, specifically something called the Battle Management Center, or BMC. You can think of it as the brain of the whole operation. It takes all the data from every single sensor in the network, mashes it all together, and creates one single, easy-to-understand picture of the entire airspace for the commanders. No more guessing, just total clarity.
Okay, so you've got this unified picture. How do commanders actually use it to coordinate an attack? Well, that brings us to the concept of the kill box. A kill box isn't a physical thing. It's a defined three-dimensional block of airspace. It's basically a zone that commanders draw on a map where friendly forces are cleared to engage and destroy any hostile targets they find. It's a way to organize the absolute chaos of battle and make sure that all your different weapons, from jets to ground-based missiles, can work in the same area without, hitting each other.
And the intelligent process that happens inside that kill box, the thing that decides who shoots at what, has a name: TEWA. That stands for Threat Evaluation and Weapon Allocation. And this right here is the real heart of modern networked air defense.
This flowchart breaks it down beautifully. First, all the sensors in the network detect incoming targets. Then, the TIWA process kicks in. It's this super smart algorithm that evaluates every single threat, its speed, its altitude, its path, and then automatically assigns the best possible weapon to take it out. Honestly, think of it like the defensive coordinator of a football team who sees the entire field at once and instantly assigns the right players to cover the right opponents, all in a fraction of a second. It's incredible.
So all of this leads us to the biggest takeaway and a little glimpse into where all this tech is headed.
So if there's one thing to really get from all this, it's this. The whole focus of military power in the air has shifted. It is no longer about who has the biggest or fastest or most powerful missile. The real advantage, the real power, now comes from who has the smartest, most integrated, and most collaborative network. The power is in the system, not just the weapon.
And that leaves us with a pretty deep question for the future, right? We've just seen how these systems use computer assistance to make split-second decisions. So, as these networks get even smarter, even faster, and more autonomous, what does that mean for the human in the loop? What is a battlefield that's partly run by intelligent, interconnected machines? What does that actually look like? That's something we're all going to have to think about.